In this video, I'm going to show you how to find the area between two curves. Find the area of the region bounded by the graphs of y equals x squared plus 2, y equals negative x equals 0, and x equals 1. Well, I've taken the liberty to already sketch these ahead of time. And the first curve in red, y equals x squared plus 2, is a parabola shifted 2 units up, and that's drawn over here. The second curve, y equals negative x, is a line with a negative slope. I've drawn that over here in blue. And the two purple lines, x equals 0 and x equals 1, are both vertical, and I've also drawn those as well. Now, when we look at that graph, there's a lot going on, but we need to keep focus on what our intention is, and that is to find the area of the region between these curves. So I'm going to highlight that for you now so you know exactly what we're focusing on. Well, you might also notice that at the top of the page I've included the area formula for finding the area between two curves, and it looks like this little a got cut off, so I'm going to just put that back on there. Alright, so the first step is to draw the sketch, and that's now done. The second thing is to draw a representative rectangle, and right now that's not going to make a whole lot of sense why this is even necessary, but as we come to our fourth or fifth video, you'll see why this is going to be essential, and for subsequent units in this chapter it's going to be even more important. So I'm going to draw a representative rectangle, which is going to be a rectangle which connects the top curve to the bottom curve. So I'm going to go ahead and do that now. Okay, so this curve over here is our top curve, and this curve down here is our bottom curve. And this is the representative rectangle that connects the two. Now I'm ready to set up my definite integral. Area is going to equal the definite integral of the top curve, which is x squared plus 2, minus the bottom curve, which is negative x. And now the question I want to ask myself is, this representative rectangle, which axis is it perpendicular to? And the answer for this problem is the x-axis, which makes this a dx problem. Not all questions will be dx questions, but this one is a dx question because the representative rectangle is perpendicular to the x-axis. So I'm going to write dx, and that also tells me that my lower and upper limits of integration are going to be with respect to x. So this tells me I'm going to need my low x here, and I'm going to need my high x here. Well, the lowest x value that I see in this region is 0 over here, and the highest one that I see is 1. So there's my setup. The next thing I can do is simplify. And when I clean up the algebra on the inside, I end up with x squared plus x plus 2. Now, when I integrate, I'm going to end up with 1/3 x cubed plus 1/2 x squared plus 2x. And this, of course, is going to be evaluated from 0 to 1. Well, the first thing that I'm going to substitute in for is plugging in 1 for all x's. Typically, I'd next plug in 0 for all x's, but that's just going to eliminate the whole second part of the problem, so I don't need to do that. Plugging in 0 is always a great thing because it eliminates most of the work. So now I'm just going to clean this up. And now I'll rewrite these with a common denominator. 1/3 is 2/6, 1/2 is 3/6, and 2 is 12/6. So in the end, we get an answer of 17/6. But now I'd like to show you how to do this on the calculator. Okay, so here's the calculator. I've turned it on. I'm going to go to the y equals screen, and I'm going to let y sub 1 equal the first curve, x squared plus 2. And then I'm going to scroll down to y sub 2 and make it negative x. And now I'll graph just to see that the graph that shows up here is the same as the one that I was working with. And it's our parabola and our negatively sloped line. And now I'm going to have the calculator do all the integration that I just did by hand as a way of checking. So I'm going to go to the home screen, and I'm going to use the integration feature of the calculator, which is Math 9. I'm going to integrate with a lower limit of 0, an upper limit of 1, and I'm going to be integrating the top curve minus the bottom curve, or in this case, y sub 1 minus y sub 2. And I'm going to be integrating with respect to x. When I press enter, I should get the equivalent of 17/6. Let's see. I'm getting 2.83 repeating, and as a final check, let's do 17 divided by 6, which is what we got when we did it by hand. Yes, perfect. The answer is confirmed.